In this video, we're going to learn about isosceles and equilateral triangles. Quick review of vocabularies. Remember, isosceles and triangles are, are those triangles with, if I have to draw this here, that this side and this side. So if I have ABC, AB and BC are congruent, and AC is not congruent with anybody. An equilateral triangle, if I have PQR triangle, R, that is, and all three sides are congruent. And again, those little ticker marks represent congruency. Okay, so maybe I'll do 2. Okay, there we go. So now in this ABC isosceles triangle, the congruent two sides AB and CB are called legs, whereas the bottom part AC is called the base. Base angles, though, are these two angles that sits right here. And because these two sides, AB and BC, are congruent, then these angle A and angle C are congruent. These two base angles are congruent. So that's just some basic review about isosceles and equilateral triangles. Now let's look at this theorem, which we just repeated. If two sides of a triangle are congruent, like AB and AC are congruent, then the angles opposite of them are congruent. In other words, when I'm looking at this side, AB, the corresponding angle to that is angle C. It's the opposite of this side. Now if I look at AC, I didn't draw that right. I look at AC there. The corresponding angle to that is angle B. It's always opposite of this side. And angle B and angle C are congruent because AB and AC are congruent because it's a isosceles triangle. So here it is. It tells us, here's an example. We have to find this measure for this angle L. Now we know this is an isosceles triangle because of these two ticker marks right there. And because the two sides, two legs are congruent, these two base angles, angle L and angle N, have to be congruent, and they have to have the same measure right here. And therefore the answer to that is angle L equals 52 degrees because it's congruent to angle N. Here's another theorem. It states that if two angles of a triangle are congruent, if two angles of a triangle are congruent, then the two sides opposite them are congruent as well. Okay, so that's an extension of what we just learned. If two angles, especially if the two base angles are congruent, then the sides opposite of these two angles are congruent. So in this case, AC has to be congruent to AB. That's a B. AB right there. And let's look at an example here. We have to find the value X in this. Do we know if it would be nice if we know that these are equilateral. I don't know if we know. It's not given. But what's given is that these two angles at the base here are congruent. So by the converse of the base angle theorem, which is right here, what we just learned, which says if the two angles are congruent, their two opposite sides are congruent. And so if we have to write this reason for this is converse of the base angle theorem. TS has to equal TP, right? If the two angles are congruent, the two sides opposite of them are congruent. And therefore, x plus 3 has to equal 12. And if you to substitute for TS and TP, because TP is 12 and TS is x plus 3. And if I do my arithmetic correctly, I subtract 3 from both sides. my answer to x is 9. Okay, the math part is not hard, the understanding of it, and make sure you know how to state the theorems correctly. Here's another theorem. This one is Equilateral Theorem. And it says that if a triangle is equilateral, again, that means all sides are equal, all three sides are equal, then it is then it is equiangular. So here is just some symbols using some symbols to represent the same things. It says if the three sides AB, AC, and BC are congruent, then angle angle B and angle C should be all congruent to each other, and as illustrated in that diagram below. That's Equilateral Theorem. Equiangular theorem, now we start with the angles. So if it says if a triangle is equiangular, then it is equilateral. So it goes backwards. And if the three angles are congruent as it states there, then AB is congruent to AC and it's congruent to BC. Okay? Let's look at this example here. It says, find the length of each side of the equiangular triangle. So it's already given that these three angles RQT are all congruent, and therefore this is an equilateral triangle. Equilateral. Now 3x should equal 2x plus 10 because all three sides are the same. And if I subtract 2x from each side, I should have 1x left on the right-hand side, and on the right-hand side I only have 10. And 3 times 10 equals 30 because I just substituted 10 for x in this part. And that's how I found out that each side of the triangle is 30. Okay, guys, I hope this is helpful. Let me know if you have any questions.